This lesson is based on the sum to infinity. First of all, let's see what is an infinite geometric series. An infinite sequence is a sequence whose terms continue forever. Now let's take a geometric progression with first term a and common ratio r. So the sequence will be like this: AR square, AR cube. It continue like this. There is no n. There is no last term. So this is an infinite sequence. Now, if we want to find the sum of this infinite sequence, let's consider the geometric series having n terms. Consider the geometric series A plus AR plus AR square plus AR cube plus up to AR power n minus 1. So we know the sum of this sequence, that is the sum Sn, is given by Sn is equal to A into 1 minus R power n over 1 minus R. Now what will happen if R lies between minus 1 and 1? Here n is getting larger. We are trying to find sum for this infinite geometric progression. So this is the aim of this lesson, to find the sum of the infinite geometric progression. Now we are considering the sum of the first n terms. So this we know. Now if R lies between minus 1 and 1, then as n gets larger and larger, this Rn will get closer to 0. Here, because it is an infinite series, n will keep on becoming large. So as n gets larger, this R power n, when R lies between minus 1 and 1, this term, this R power n, will get closer to 0. We say that as n tends to infinity, R power n tends to 0. Therefore, as n tends to infinity, this part A into R power n over 1 minus R will tend to A 1 minus this R power n. We just saw above that it will tend to 0. So we replace R power n by 0. And here we have 1 minus R in the denominator. So we obtain A over 1 minus R. So this gives the result S infinity, because we said that n is tending to infinity. So we obtain S infinity is equal to A over 1 minus R, provided, this is a condition, provided that modulus of R is less than 1, or R lies between 1 and minus 1. These two are the same. So this is a condition for us to have sum to infinity is equal to A over 1 minus R. So this is the sum of an infinite geometric series. So I'll explain again. We obtain sum to infinity, this formula, from the formula of Sn. That is a formula for the sum of first n terms. So in the previous lesson, we saw that the formula is A into 1 minus R power n over 1 minus R. Now, if we have this condition, R lies between minus 1 and 1, so n is getting larger because it is an infinite series. We will see that R power n, this term, will get closer to 0. When we replace, suppose we have half power 10. This will tend to 0. Half, as n increases, half power 20. It becomes closer to 0. So this is the notation that we use as n tends. This arrow means as tends. N tends to infinity. R power n tends to 0. And hence, we obtain A in the formula of Sn into 1 minus this R power n. We replace it by 0. The denominator remains 1 minus R, and we obtain A over 1 minus R as a sum to infinity. Let's consider an example. The first four terms of a geometric progression of 5, 4, 3.2 and 2.56. Write down the common ratio. The first part, the common ratio R is equal to, so we can take the second term, divide by the first term. We obtain the common ratio as 4 over 5. Now, sum to infinity, the formula is A over 1 minus R. And here A is 5. The first term of the geometric progression is 5, and R is equal to 4 over 5. So it's 5 over 1 minus 4 over 5, which is 25. Very easy. Sum to infinity, A over 1 minus R. We just have to know the first term and the common ratio of the progression. We proceed with a second example. The fourth term of a geometric progression is 48, and the sum to infinity is 5 times the first term. Find the first term. The fourth term is 48. U4, which is AR cubed, fourth term of a geometric progression. So A and R both are unknown. So we take them to be A and R. So fourth term is written as AR cubed. This is equal to 48. And then the sum to infinity is 5 times the first term. Sum to infinity is equal to 5 times the first term. So sum to infinity, it is A over 1 minus R is equal to 5A. We can divide both sides by A. We obtain 1 over 1 minus R is equal to 5. So 1 minus R is equal to 1 over 5. R is equal to 4 over 5. So this is the common ratio, 4 over 5. Now, here, we replace R by 4 over 5 is equal to 48. So A, 64 over 125 is equal to 48, and A is 48 multiplied by 125 over 64. We obtain A as 93.75. So we just have to apply the formula for the fourth term of a geometric progression and the formula for sum to infinity. We have two equations which we solve simultaneously. So here we obtain R as 4 over 5. We replace it in this equation. We obtain A as 93.75.